Section 6.2, Closed box and open box testing. There are two ways that software engineers commonly test their code. The first is called closed box testing, and this approach assumes you know nothing about how the code works. As such, this kind of testing involves varying the inputs and observing the outputs. We often see closed box testing applied to functions or entire programs. The advantage of closed box testing is that you don't need to look at the code to perform the tests and can therefore focus simply on the desired behavior. The second approach to testing is called open box testing, and in this approach, we look at the code to see where the errors might occur. The advantage of open box testing is that by looking at the particular structure of the code, we may see where the code is likely to fail and can design additional tests specific to that code. We'll use both closed box and open box testing to come up with test cases that combine to strengthen our testing. A brief summary of closed box and open box testing appears in Table 6.1. In this section, let's look at how we might test some functions using these approaches.
Table 6.1. Brief overview of closed box and open box testing.
Section 6.2.1. Closed box testing. Let's imagine we're trying to test a function that takes in a list of words, strings, and returns the longest word. To be more precise, the function signature would be.
See this code?
The expected input is a list of words. The expected output is the word in that list with the most characters. In the event that multiple words are tied for the most characters, it should return the first word of that length. Shorthand for expressing test cases. When writing tests for a function, the standard format is to write the function name and its input along with the desired outcome. For example, the call
See this code?
Means that if we call the function longest word with the input list, A, B, B, C, 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 then the value returned from the function should be CCC. There are two categories for which we typically think about writing test cases. Common use cases. These cases include some standard inputs you could imagine the function receiving and the corresponding result. Edge cases. These cases are uncommon but possible cases that might break the code. These are inputs that might test some of the rules for the function in more depth or contain unexpected inputs, for example, a list with all empty strings. Looking back at our longest word function signature in the previous example, let's think about some test cases we might use to test it. Later in the chapter, we'll see how to actually run these test cases to determine whether our code is working correctly. Let's start with common use cases. We would likely want to include a test with just a few words where one word is longer than the others.
See this code?
Here's another test with more words with the longest word appearing elsewhere in the list.
See this code?
And last, let's have a test with just one word.
See this code?
If the program is working for these common uses, our next step would be to think about some edge cases. Let's consider some edge cases. Say we want to check whether the function conforms to our description by returning the first word when there are multiple words of the same length. This test may be considered a common case or an edge case, depending on whom you ask.
See this code?
What do we do if all the words in the list have no characters? A string with no characters is called an empty string and is written as just an empty pair of quotes. If all we have is a list of empty strings, then the longest word is just the empty string. So, a test with all empty strings should just give us back an empty string.
See this code?
The term edge case comes from the fact that errors often happen at the edge of execution, meaning either the first or last element. In many loops, mistakes can be made when the loop is starting, for example, forgetting or mishandling the first element in the list, or at the end, for example, forgetting the last element, or going past the end of the list and trying to access an element that doesn't exist. Especially when the code is likely to have loops processing many elements, you'll want to watch the behavior at the start and end of the loop. Incorrect input testing. Another category of tests will test the function on how it responds when given incorrect input. We won't talk about this much in our book because we're assuming you're correctly calling your own functions, but in production code, this kind of testing can be common. A few examples of calling this function with incorrect inputs might be to give the function a non-existing list by using the value none instead of an actual list, for example, longest word of none, to give the function an empty list, for example, longest word of empty list, to give the function a list with integers as input, For example, longest word of 1, 2, or to provide a list of strings, but have the strings contain spaces or more than single words. For example, longest word of hi there, my friend. It's hard to say what the function should do when given incorrect input, and programmers need to decide whether they care about this in larger code bases. But we'll ignore this category of tests in this book, because we'll assume you'll call your own functions in ways that the functions are designed to handle. Section 6.2.2. How do we know which test cases to use? In Chapter 3, we discussed that good testing involves capturing different categories of function calls. One way to find these categories is by using the types of parameters and varying their values. For example, if the function takes a string or list as a parameter, it may make sense to test the case when that string or list is empty, has one element, and has multiple elements. If we're trying to test multiple elements, we might use 4 elements, for example. It likely also wouldn't make sense to test with 5 or 6 elements or more, because if our code works with 4 elements, it's unlikely that something could suddenly go wrong when we increase to 5. Sometimes, some of these test cases may not make sense for a given function. For example, it wouldn't make sense to ask for the longest word in a list that didn't have any words in it, so we wouldn't test the empty list for our longest word function. As another example, if a function takes 2 numbers as parameters, it may make sense to test when one number is 0, both numbers are 0, one number is negative, both numbers are negative, and both numbers are positive. Another way to find categories is to think about the specific task of the function. For example, for our longest word function, it's supposed to be finding the longest word, so we should test that it's actually doing that in a typical case. And, if multiple words are the longest, it's supposed to return the first of those, so we should have a test case where the list has multiple words that are the longest. Finding the categories to test is a mix of science and art. We've given you some rules of thumb here, but what counts as useful test cases often depends on the specific functionality being tested. As is so often the case, practicing your testing skill is the best way to improve your ability to write useful tests that ultimately help you make your code better. Section 6.2.3. Open box testing. The big difference between open box testing and closed box testing is that open box testing examines the code to see if there are additional kinds of test cases to check. In theory, closed box testing may be sufficient to fully test the function, but open box testing tends to give you more ideas about where the code might be failing. Let's say we asked for Copilot to write our longest word function and got back the code shown in the following listing.
Listing 6.1. Function to find the longest word, incorrect.
For this example, we intentionally introduced an error in the code to help explain the role of open box testing. Let's say that when you were thinking through your test cases, you forgot to test what happens when there are 2 words in the list of words that both have the most characters. Well, reading through this code, you might spot the following if statement.
See this code?
When reading the if statement, you might notice that it's going to update the longest word in the list of words when the length of the most recent element is greater than or equal to the longest word we've seen so far. This is a mistake. It should be greater than, not greater than equals, but suppose you aren't sure. This would motivate you to write a test case like the one we described previously that has multiple words, more than one of which is the longest.
See this code?
This test will fail with the code in listing 6.1 as it would return dog, rather than the correct answer of cat. The test failing is valuable information that the code in listing 6.1 is incorrect. As we've said, open box testing is useful because it leads to test cases that follow the structure of the code itself. For example, if our code is using a loop, we'll find that loop when doing open box testing. The loop in listing 6.1 is correct, but by seeing the loop in our code, we'll be reminded to test the edge cases to make sure it's properly handling the first element, the last element, and an empty list. In sum, knowing how the code is processing the input often offers insight into when the program might be misfunctioning.